Okay, Math 9, this is not a bonus video, but I would say a video that works on extending concepts, so really sophisticated level of understanding, and we're getting up to the most complex types of exponent questions you can expect. So that is when we mix together variables and numbers. So the most important thing to consider is this. Most people see this and think 4r is this thing on its own because that's how we write it. But what it actually means is 4 times r times r. Well, obviously this times r, but 4 times r, this part is the same as just saying 4r. We just say 4r because it's convenient, but it's important to understand the difference. Because really what we have here is we have 4 times r over r. Now, if you want to cancel this using factors, you can do that right away, right? We have all factors on the top, same factors cancel top and bottom. So you'd end up with 4 to the power of r. But if you think about this as exponents, you have r to the 1 times r to the 1, which means we have r to the 2 over r, which is r to the 1, and then you would subtract the exponents of the common base, and the common base in this case is the r, right? You can have common base of letters, numbers, or a combination of the two. So for the next one, we have 15, and then t to the 4 times t to the 5, which means we have t to the 4 plus 5 because we can combine those t's on the top, right? We can combine just that action there. And then on the bottom, we have t cubed. So this simplifies to 15t to the 9 over t cubed. So we get 15t, and now we common base here and here, 9 minus 3 is 6. So just because the 15 is in the question doesn't mean it needs to be included. It still exists. We just don't have any exponent laws we can do with it. So what if they get a little bit bigger? So here's another scenario, right? Well, here I have power to a power. So first I have to multiply that in there, and I have to multiply that in there. It's going to get rid of my brackets, right? So now I have 2 to the 6 over 3 to the 4 times 2 to the 12 over 3 to the 3. And now what you'll notice is these are multiplying together. So I have 2 to the 6 times 2 to the 12 over 3 to the 4 times 3 cubed. And I have a common base on both the top and bottom, so I can combine those. I have 2 to the 18, so I do 6 plus 12, and I have a 3 to the 7 because I do 4 plus 3. But from there, I can't do anything else. I'm done. You need to know when to stop. You don't have a common base, so there's nothing more that you can do. That is it. Do they get harder? Of course they do. So here we have, and this is why it's important to understand, you have 4 times a times b to the negative 1, and all of that is to the 3. So this 3 has to multiply into that exponent, which is a 1, that exponent, which is a 1, and that exponent, which is a negative 1. So we actually end up with 4 to the 3, a to the 3, b to the negative 3. And now those brackets are gone. And we have to do the same thing here, but it's going to go 2 to the 1, and then a to the 2, b to the 3. So we're going to have 2 to the 1, or 2 now, and then a to the 4, b to the 6. And now we're multiplying all these things together, which means you can understand that you can rearrange multiplication, right? 2 times 3 times 4 is the same as 2 times 4 times 3, and 3 times 2 times 4. Order doesn't matter. So we can rearrange this statement so that it looks more user-friendly. We have 4 to the 3 times 2 squared, and then I'm going to do my a's next, because then I can see that my numbers go together, my a's go together, and my b's go together. Now you don't have to do this, but I'm showing you this just so you can get it a bit clearer in your mind. And now for the numbers, since you don't have a common base, just compute them. So 4 to the power of 3 is 64. 4 times 4 times 4. And then 2 to the squared is 4. So in the end, you could multiply that together. You can use a calculator for that, or a multiplication table, or good old-fashioned mathematics. But that's 256. And now we have a's here, and we're multiplying them. So we add the exponents. We get a to the 7. Then we have b's here, and we're adding the exponents. So we get b to the power of 3. So that is how you would manage a multivariable, multi-numerical complex exponents question. You're going to see a lot of those in grade 10, so it's worth getting a bit of practice here. So here's the last one here. Now again, if you have exponents outside, you got to multiply them in. So multiply in, multiply in. This one here is going to multiply in, multiply in. So we're going to get x to the negative 4, y to the negative 4 times x to the 6, y to the 6, all over x to the negative 2, y to the negative 2. So where does that leave us? Well, rather than rearrange this time, know that you can combine x's with x's. And negative 4 plus 6 gets us x to the 2. Then you can combine y's with y's. And negative 4 plus 6 gets us y to the 2. And on the bottom, we have x to the negative 2, y to the negative 2. Now we are subtracting exponents because we're dividing, and you divide x's with x's. So 2 minus negative 2 is 4. So we get x to the 4. And then y, we have the same calculation, y to the 4. So it becomes really a stepwise type question where you do one step after another, and it slowly makes your question more and more manageable. I know that the steps can look scary. If you look at this question right off the bat, you might be like, oh man, look at all those negatives, look at all those exponents, there's different letters, what is happening? But if you do it one step at a time, it makes things easier and easier and easier. So that's the most complex we're going to look at in grade 9, but be ready for questions like that in grade 10. Keep it up.